So let's just start having this long example, and I'm going to solve it. This example is from previous chapters. Pipes in series and the parallel pipes. So basically, this is the question. It didn't have any figure or picture. So I asked ChatGPT to give me a picture. I think visual picture helps you better. So the question is the question. Everything is the same. The picture is from AI. Just ask it to produce it for me. Okay. Maybe I can copy and paste this one here. Probably I need that. So I will put it here for myself when I'm solving that. And one more time. So just before I start solving that, first of all, it says that I have two parallel pipe. Probably it's talking about a situation. You have each pipe characteristic, the length and the diameter. So the diameter and the lengths are mentioned here. The lengths are the same, the diameter differs. And it asks how much is the head loss. Next one, you have two pipe in series and the lengths are different, the diameter are different as well. And it asks for head loss again. And when we are talking about head loss, probably Darcy-Weisbach or Hazen-Williams comes to your mind. You should look at your data. Data says that you have C. Darcy-Weisbach or Darcy-Weisbach doesn't have C, it has F. So it clearly shows that you should go for Hazen-Williams. I will start with part A, which is the parallel one. A. Parallel pipes. Hazen-Williams formula is the one that I'm writing here. L divided by C 1.8 divided by D 4.87 multiplied by Q 1.52. You can start from scratch here, but I would like to make it easier. So I will call this one R, the whole package here, multiplied by Q. It's an extra step, but it causes less error in solution. I have two pipes, so I should do it twice. HF1, R1, Q1, 1.852. HF2, R2, Q2, 1.852. So I will start with R1, 10.7 multiplied by 150 divided by 20. What's the D in meter? 4.87. For R2, I have the same. Length is the same. C is the same. I remember that diameter was not the same. I'm gonna double check the numbers. Seems correct to me. If you find the first one, it is something around that. My solution is a bit different with what I have in a real solution, but they are so close. So this is 2,300. This guy, this is 500. So I have R1 and R2. Now I should use my knowledge and notice that for parallel one, which one was equal, which one was the sum. As you remember, Q of total is Q of line 1 and line 2. So I can say QT is Q1 plus Q2. Without this equation, you cannot solve it. So again, remember, when I'm talking about parallel, it means that I should know HFs are equal, Qs are the sum. For series, vice versa. Qs is the same, HF is sum of all Hs. Based on this, I will call that one star, so replace the star here. Instead of QT, I will write HFT divided by RT, and for the power, I just need to reverse it. Same thing for this one. Same for the second one. I just replace it with the main equation that I have. For sure, you have another ways to solve this problem. You can start from scratch, do it, but I find this way easier. Which parameter here could be canceled out from both sides of equation? Which one? Power, you mean? You cannot do it based on mass when you have something equal to something plus something. If it's the multiplying, yeah, but for this one, no, you cannot do that. It's like you said that A, B, C, it's not equal to A equal to B, C. Mathematically, it's not happening. One more thing. Cooper, seems that you are going to give me the correct answer. Pretty sure that. Okay. So, Tanner, based on the parallel rule, which one is equal in all of them? Yeah, losses. No matter what, losses are the same. Consider that I multiply them by 2. You can cancel out 2. So HF is the same in all of them. I can just write this guy equal to 1 divided by R1 plus the last one. And you should replace R1 and R2 and you are done. Which I don't have a space, so I should go for the next slide whenever you are ready. So replace R1, R2. Here we go. Equal to the first one is this number, the next one is this number based on what I calculated. Because I added this example recently, So I did the calculation myself. The answer is very close to what I'm going to post. And if you do that, you can say RT equal to 1 divided by 0. Sorry, you have another 0 here. Let me write that. Which gives me RT equal to 282, which I can say HF of T equal to RT QT. So 282 multiplied by QT was the total Q. This is QT. And you have 7.5 meter of HF. The second part is the same. You just need to know the rule for series pipe. In this case, HF should be added together. Discharge are the same. So I will be faster writing the second one, but I think I need an extra slide for that if you are done. So part B, which is series pipe. Again, RT is R1 plus R2. I'm not going to write it one more time. For R1, you have 10.7 multiplied by L1 divided by C1, 1.852 multiplied by B, 4.87. 10.7, be careful, L1 is 30. Yeah, C1 is 110. D1 is 0.34.87, which gives me, I think I calculate that one, this one. R2, same thing, but L2. L2 is 100 meter. C1 is 110. And D2 is 0.25, which is equal to 153. So RT is the biomass. And again, HF equal to R multiplied by Q. I started from this part. These are series. Again, if you confuse, I'm going to tell myself that in series, the same water pass the different pipes. So Q are the same, but HF of total is HF in all pipes. Follow this one. Says that RT, QT, R1, Q1. Don't forget this one here. R2, Q2. If you find any mistake there, just let me know. I may write some incorrect numbers. Which one could be canceled out from both sides? This time is discharge. They are the same. So you just need to write that HFT is equal to R1 plus R2 QT 1.2, which means 171.9 multiplied by Q is the same. My God. There we go. 1.852, which is equal to 4.5 meter of losses.